Hi, can you see me?
Yes, hi.
Hi, everyone. We will start with the presentation of Lars Russ.
Yes.
Yeah, okay. Jan Tro, Violeta Kucharska, and Anna Viviora with the presentation with title Adaptive Dynamical Systems Modeling and Transformational Organizational Change with focus on organizational culture and organizational learning.
Exactly.
Please, Lars, go, please, with your presentation. Thank you.
Welcome everyone to my presentation from the paper that me, Lars Russ, Jan Troja, Violeta Kucharska, and Anna Viabara wrote together. It's about, like already I said, computational modeling of transformational organizational change with a focus on organizational culture and learning in a hospital-related safety culture context. To introduce the topic, it becomes more and more apparent that there's an urgency to adapt our systems and organizational structures to the changing circumstances and learn how to facilitate sustained change. Organizational culture is a priority nowadays, especially after COVID-19 put further pressure on our public healthcare systems. The concept of healthcare safety culture is closely related to constant learning culture, which is composed of components as learning climate and mistakes acceptance as a natural part of constant learning. There's two approaches nowadays on how to see organizational change. The classic approach is to see organizational change as an external process that can be applied to any organization. But the more recent, more current approach is the dynamic adaptive systems approach, in which organizations are seen as complex adaptive systems, in which organizational processes are dependent on the interactions of independent individuals. So in this approach, change isn't seen as something applied to the company, but a change within the systems of the company, in adaptation of an organization towards the new context or environment. And especially in this field, computational modeling and formalization of this organizational change and learning process is still largely unexplored. So we aim to provide an adaptive network model of transformative organizational change and translate a selection of organizational learning and change processes into computationally modeled processes. For that, we conducted a literature review and where we found that there is right now a systems model of organizational change that was proposed by Maas and van Hotkamp that sees organizational change not as a linear process, but as a multidimensional mechanism in which an organization adapts to its influences. Organizational change is hereby significantly influenced by the organizational culture or how the organization deals with new input. The culture of an organization thereby is mainly shaped by its members' shared values, norms, and assumptions about reality. And in this context, a constant learning culture aims to provide an environment for sustained learning possibilities or change possibilities for transformation for the organization on both the personal and the organizational level through mistake acceptance and collaboration-driven organizational culture. Organization could be seen as dynamic adaptive systems on individuals' actions and processes of actions and sense-making. In a systems perspective, these transition processes are emergence of the interplay of various actors pursuing their interests, but the overall direction is usually driven and propagated by actors with a larger plan or visions in the context of organization. This would be leaders or the managers. Transformational change is characterized by the reshaping of strategies and behaviors, as well as a shift of values and culture. And this organizational learning usually takes place by feed-forward learning, in which information processes get propagated towards higher organizational levels, and feedback learning, where changes on the organizational or team level get propagated back towards lower levels of the organization. While this whole research is quite far-reaching, we decided to have a research focus in which we try to first confirm if the explored dynamic systems view of organizations can be translated into the self-modeling approach that we use for our simulation. But also we want to try to verify if a shift in learning culture happens towards a constant learning culture if we apply those organizational change processes. To be more precise, however, we want to also explore the organizational learning mechanisms effects themselves and their effectiveness in correcting inaccurate mental models, organizational processes, and particularly feedback and feed-forward learning, both in organizational and at team level, learning from mistakes brought forth by Kushaska, and diet learning. As also, we want to see if leadership inspired or instructed organizational cultural change, incentives, for example, workshops, or like the restructuring of organizational structures is valuable or is effective. For this, we will use the adaptive computational network model approach proposed by Jan Troy. And in this, we have a network model, which is mostly defined through its connections that translate between real-world causal relations into a network structure, which weights demonstrates the importance or the strength of the connection, a timing which is done by a speed factor that represents the rate of change of certain values, and aggregation functions that determine how multiple inputs to a node are combined. We reach adaptivity in this model through higher order self-models that usually consist of self-model replication states and enable an adaptivity and reactivity of the weights, the speed factors, and the network characteristics, like the parameters of the combination function. Our model and our simulation surrounds a hospital-related safety culture context in which we model a 3-step task as mental representations of all entities in this simulation. We have 4 young doctors that have a representation of this task in their head. We have 2 teams where the shared mental model of this task is saved, and 1 experienced doctor, which also has the mental representation, and 1 organizational mental representation as well. This task could consist of anything from CPR to a more complex, more step process. But for the sake of the simulation, we kept it as a generic 3-step process in which the perfect representation would be task 1 is executed, then task 2, then task 3. But if error can occur if task 1 gets executed and task 2 gets skipped, and we try to prevent that, we try to save this. For this, we have the base level construct of just the real world cause and the mental representations. The second order describes the weights of the different connections, as well as an error detection mechanism of the real world occurrence of the task. So if we detect an error happening there, it triggers organizational learning mechanisms. Those we see on the second order that influence the first order weights, which then influences the base level and the actual mental representations. Here we have the different mechanisms that we examine. We have feed forward and feedback learning in purple, in which we have in monthly meetings feedback and feed forward towards the organizational level to build a shared mental model on the organization, but also back to learn from this shared mental model. We have the daily shift meetings, in which on a daily basis the teams meet and the young doctors meet in their teams with the experienced doctor to talk about the recent shift, to talk about the mistakes happening there, where also feedback and feed forward learning happens, but not on an organizational, but only on a team level. We further also have a we also have in yellow the states and the mechanism that detects mistakes, which gets triggered when on the first base level in the real world a task gets performed wrongly, in which first the error gets detected, the young doctor is proactive about it, registers it with them, what then creates the supervision reflection in which he and the experienced doctor talk about the mistake and take the lessons from it in the form of diet learning. And the last thing that we have as a mechanism is in red, which describes the restructuring of organizational structures, which changes some adaptivity parameters within the aggregation functions. The light blue colored nodes are just internal nodes to control the simulation, so they're not really important for understanding. When we run the simulation, we first run the learning by mistakes mechanism. Then we simulate 3 days of daily reflections. After that, we simulate a restructuring of the company or organization, in this case of the hospital context. And then we simulate a monthly meeting, a monthly reflection upon everything. We see already that when learning from mistakes, there's a huge change in the mental representations towards a corrected representation. We see that in yellow, for example, when an error occurs, it triggers the error detection mechanisms, which triggers the young doctor to be proactive about it, which then triggers a cooperation between the experienced doctor and the young doctor, which elevates, for example, the brown lines that you see on the left, on the bottom, which elevates them to a higher point, to nearly 1, towards the correct representation, towards the correct understanding of after task 1, task 2 follows. You also see that the wrong connection that was at point 0.9 in the beginning already goes lower to 0.3, which represents the shortcut that some doctors will take from task 1 to task 3. So already here we see a correction of the mental representations, but not a full correction. Then the next time we have daily shift reflections, so a daily reflection upon the mistakes or challenges occurring in the context. And in red highlighted, there's one of them mental representations of the young doctors of the correct task succession. But you see that every time when we trigger the first feed forward part of the daily reflections, in which they only share their knowledge, they only share their mistakes, there's no learning yet, because it builds the team mental model, the mental model on the team level. It creates it only then. Then on the second time, where actually the feedback learning happens and the young doctors' mental representations can be influenced by the team mental models, we actually see that it corrects to a certain degree. We see also, like, over the 3 shifts, the 3 days actually modeled, we see the change actually applying and changing from a quite wrong mental representation towards a correct one. Also, when we see it in more detail, we really do see how the team mental model gets built, the team mental model gets adjusted, and then it influences the young doctors' mental models. We also have the monthly reflection, and here we actually examined how much the change of both of the reflections reflection would be if there was a restructuring in the teams, or if there was no restructuring in the teams. When we had a organizational restructuring, we saw that the learning effect was quite effective. We see a huge change. However, when there was no change teams, so when there was no restructuring of the company and the focus of the doctors was less, we see that there's only less of a learning effect. So what can we conclude from this? Overall, the model successfully showed emergent behavior, reflecting the empirical findings in the discussed literature, confirming its validity. We also observed and confirmed for the model that learning from mistakes is one of the most powerful tools for individual learning. The simulations also show that the daily shift reflections have a constant and robust positive impact on the correction of the mental models, suggesting this tool as the most reliable mechanism to choose. The model as well demonstrates that a cultural shift towards a constant learning culture, verifiable by many and interacting learning opportunities, occurred. Lastly, the model and its results further confirm that the self-modeling approach by Jan Dreuer is a suitable approach to formalize the systems model of organizational change brought forth by Maas and van Houtkem, and the proposed dynamic systems view of organizations brought back by Fowler, Hazy, and Silverstein. However, this research obviously also has limitations. It's only simulation, and the simulation is only scenario bound and only reflects some organizational learning mechanisms. A further advanced model should also integrate observational learning for the task observing doctors, or could integrate counterfactual thinking as a learning and decision-making mechanism as proposed by Balvanka and Troyer. Also, a combination with additional computational models in this domain could be added as well to create a more and more holistic representation of organizational transformations. Lastly, the translated mechanisms of this model can be extracted and reused in other related models. Therefore, future research suggests itself in an extension of the proposed model, as well as in the creation of a library of computationally translated transformative organizational change mechanisms. Yes, those are the references, and if there's any questions, I'm happy to answer them.
Okay. Is there any question? No? Okay. Thank you, Lars.
Thank you.